Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Biology Paper 2 Higher Tier, question number 9 from the top, which is from the topic on homeostasis and response. Type 2 diabetes is a condition that has become more common in recent years. Scientists recorded the percentage of people of different ages who had type 2 diabetes. The people were in different weight categories: healthy weight, overweight, and obese. Figure 10 shows the results. This is a bar graph. So you've got the age range between 21 to 44, 45 to 64, and over 64. So as you can see, the percentage of people with type 2 diabetes is actually increasing as the age increases. And the percentage of type 2 diabetes is actually higher in the obese category every single time. So give two conclusions from the results in figure 10. So the percentage of people with type 2 diabetes increases with age. And the second conclusion is the percentage of people with type 2 diabetes increases with increased body mass, or you could say weight. Two groups of scientists investigated the use of different drugs to test type 2 diabetes. In both investigations, the scientists measured the percentage of hemoglobin with glucose attached, HbG. This showed the long-term concentration of glucose in the blood. The scientists injected drug A into 175 patients with type 2 diabetes once each day. So one injection. So this is an injection, which is drug A, into 175 patients for 12 weeks. Table 4 shows the results. Percentage of hemoglobin with glucose attached. At the start is, they're starting off, the patients had 9.2. This is actually the mean value from these 175 patients. And at 12 weeks, it had dropped down to 7.6. So if I was to work that out, 9.2 minus 7.6, 12. So that's a decrease by 1.6% drop after they took the drugs. In investigation 2, 631 patients. Now that is actually a bigger number compared to the 135. With type 2 diabetes took one tablet, so that's actually different from the injection containing drug B each day. For again, is the same as the injection. A control group of 630 patients took a placebo as well. So that's actually different. So in In the first investigation, there was no control group. The scientists measured the HbG in each patient's blood at the start of the investigation at 6 weeks intervals up to 24 weeks. So you would measure at the start, let's say 0, 6, 12 and 24 weeks. So they're measuring it continuously over a longer period. In the first investigation, it was only up to 12 weeks. So this actually double the time. Oops, it's not, I missed. So 0, 6, 12, 18 and 24 weeks. So investigation 2 was carried out for a longer period of time. So figure 11 shows the results. So this is at the start. So starting percentage is 0. Doesn't mean that the mean change. So this is actually the mean change rather than just the mean. In percentage HgB, in drug B, it actually lowered really fast in the first 6 weeks. It is lowering in the second 6 weeks, but not that much. And third, the drop is slightly less, and actually it increased in week 24, between week 18 and 24. It's worthwhile spending a lot of time actually interpreting the information and understanding what they're actually asking before attempting to answer the question. So for the patients treated with drug B, the mean percentage of HbG at the start was 8.3%. So what was the mean percentage of HbG after 12 weeks for the patients treated with drug B? So let's have a look at drug B at 12 weeks. At 12 weeks, it's this value. So that's between minus 0.6 and minus 0.7. So this should be minus 0.65. Now, if you read it from the bottom, you're going to get it wrong. So remember, it's actually negative values. So you need to make sure that you read this off correctly. So if you're starting off with 8.3%, 8.3%, and you wind up losing 0.65%. So if I take away 0.65 from that, I should get 5, 6, and 7. So that'll be 7.65%. In a person without diabetes, the HgB value is between 4.5 and 6%. When treating patients with type 2 diabetes, doctors think that an HgB value lower than 7% is acceptable. So if our blood glucose level, or not the blood glucose level, the glucose attached to the hemoglobin is less than 7%, then it's acceptable. So the question is, did the drugs actually achieve that? Now, as you can see, drug B, which we just calculated, was 7.65% after treatment after 24 weeks. So that means it didn't actually lower it to the acceptable level. And drug A, it dropped to 7.6%, very similar to the drug B, but it was still not less than 7%. Okay. Evaluate the methods used in the investigation. So if you're evaluating, you need to talk about the advantage, positives and the negatives, and then give your reasoning for it as well. So evaluate the methods used in the investigations. the usefulness of drug A and B for controlling type 2 diabetes. So let's have a look at the methods again. We've got in investigation 1, 175 patients. In investigation 2, we are testing 631 and patients and 630 patients who took the placebo. So this is actually a much larger group for type 2 investigation 2. This is an injection, whereas this one is a tablet. And this was carried out for 12 weeks. This was carried out for 24 weeks. And they've only taken in investigation 1 the reading at the start and after at 12 weeks, whereas here they've taken readings in between every 6 weeks as well. So they closely monitored it more frequently than in investigation 1. They haven't said how much drug was given in each. They haven't mentioned anything about side effects as such. Okay, so let's try and answer this. Evaluate the methods in the investigation and the usefulness of drug. So here's a answer using the information that I've just discussed. Methods are not comparable because different methods are used to administer the drugs, since drug A was an injection while drug B was a pill. So drug A acts more quickly than drug B. Injections, because it's going straight into the bloodstream, it acts much faster, whereas drug B is a pill which has to be digested. It needs to go through the digestive system and then absorbed into the blood for it to reach to the target organ. Dosage for drug A and B might differ as dosage is not stated. Drug A and drug B are tested for different times or periods, since drug A is given for a longer period of time of 24 weeks, while drug B was given for a longer period of time of 24 weeks, while drug A was given for 12 weeks. The placebo or control was only included when testing drug B, and only drug B had intermediate readings. Different sample sizes were used. Drug A was tested on 175, while drug B was tested on 631. That's not including the placebo. Different scientists carried out each investigation. There is no double-blind trial for drug A, whereas drug B, they had the placebo, so there would have been a double-blind trial. So that's the evaluation in terms of the difference. The evaluation in terms of the similarity, neither drug trial was double-blinded, because actually in B, it doesn't say they were using double-blind trial. Quantitative tests in both trials, relatively large sample size used for both drugs. So using 175 is much lower than 631, but still it is quite a big number. In terms of the usefulness of drug A and drug B, both drugs lowered HGB levels to similar levels, which is around 7.6. The first one reduced it to 7.6, which is drug A, and drug B lowered it to 7.65. Remember, that's what we calculated. Drug A reduced HGB more than drug B, because in drug A, it will start from 9. What was the value? 9.2 to 7.6, so it dropped it by 1.6%, whereas drug B dropped it only by 0.65%. Neither drug reduced HGB to an acceptable value of less than 7%. HGB increases after 18 weeks with drug B. There's no information on the side effects for either drugs, and there's no information on the trend for drug A. In order to get level 3, you need to have details about the method, and the usefulness of the drugs must be given. That's the end of the question. Thanks for watching, and I will see you in the next paper.